and sort of take us out of the darkness and into the light. And I had a similar voyage as Daphne. I'm a couple of years older, so I had struggled as a grad student for a few more years of getting it all wrong. So maybe it was more poignant for me to see the light. And I remember hearing you to say, and sort of admonishing us to all raise our sights, by which he meant sort of figuratively, that we could get to a better place, but he also meant it literally. And he had a suggestion that said, yeah, well, everybody look up at the ceiling. The ceiling doesn't have panels like that, but it has lights. And imagine the problem that if you had to quickly determine how many panels there were on the ceiling, how would you do that? And his point was, well, probably what you do is you estimate the number in this direction, you estimate the number in this direction, and then you'd multiply. And what he explained to us so well, and really struck home to me, listening to it at that lecture, was we had everyone at AI had spent so much time thinking about, well, how do you do that estimate? How do you quickly glance and estimate that there's 15 in this direction and not 14 or 15? We were all worried about that. And we weren't worried so much of, however you do that estimate, when you get the two numbers, you better multiply them together. You shouldn't add them or square them or take the sign of the square root or something like that. And he pointed out that that's what we were all doing. We were all worried so much about how to get the numbers that we were making the wrong calculations with them once we got them. So that really struck home for me. And it, we can put it in that context of what the old model was before this new model came along. And here's two of the key practitioners of the old sort of expert system model. And they wrote in 1991 about why it's hard to capture the knowledge that an expert has. Saying each of us has its vast storehouse of general knowledge we rarely talk about and or explicitly use, so we just assume that other people already know these things. Things like water flow downhill and living things get diseases. And they pointed out that since we had to know this to make good inferences, probably we had to write it all down. We had to hire experts to write this stuff down in a language that people could understand, or rather that computers could understand, so that we could make inference from it. So it's a good model, a good way of going forward. The only problem was when you actually sit down and do it, last time somebody tried, it came down to about $10,000 per page to hire somebody to write all this down in a formal language the computer could understand. And if you try scaling that up to things like the trillion pages that Google has, pretty soon you're talking real money. Now the question is, were they right? And I think they were exactly right. But even though they were right, we can still move away from this paradigm. Because notice what they said. They said, we rarely talk about this type of knowledge. Well, that's true. Rarely turns out to be about that percentage of the pages in Google. And so if all you had to go from was what they were trying to do was encode the knowledge in a pocket encyclopedia, one of those small, just 1,000-page encyclopedias. Do you remember encyclopedias? Right? And you had the one-volume ones, and then you had the big ones. They were trying to encode the knowledge in one volume one. And none of these things occur in 1,000 pages. But if you have 100 billion pages, then they do. And in fact, instead of hiring grad students to write down all this knowledge that seems so obscure, you could just go to Google, search for water flows downhill, put it in double quote marks, all the words have to come together, and the number one result, I first showed this slide several years ago, and I'm proud to say it still works. The number one result is a very nice page from preschool and K education by Emily, kindergarten. So the knowledge is there if we just broaden where we're looking. So we don't have to rely on individuals. This is the other part of what we're trying to escape from. 1956, Chomsky said, well, we couldn't possibly use probability because even with a very simple model of language use, we need 10 to the 9th parameters, and a childhood only lasts 10 to the 8 seconds, so nobody could possibly get those numbers. Turns out he was wrong, that we can get them, and one of the reasons we can get them is because we don't have to do them all at once, one at a time, one per second. Rather, we can form generalizations and initialize large swaths of them to low values, say, all at once. So, as was mentioned, Stuart and I wrote this book, first edition in 1995. We called it Artificial Intelligence, Modern Approach. And this is what we thought the modern approach was, moving away from this expert knowledge towards more data-oriented. You can just go get the data, rather than writing it down. Moving from heuristic to normative, sort of do the right thing, be rational. Moving from hand-coded to learning. And from ad hoc reasoning to this correct probabilistic reasoning, the multiplication of the tiles in the x and y directions rather than